Chapter 8, where does the time go? In Chapter 8, we're going to talk about a couple things, and this is all going to be a review for you, except we're going to add some more vocabulary. So we're going to jump right into a vocab. Right? The degree of a monomial, right? You know monomial means 1, is the sum of the exponents of all of its variables. So if I have monomials like these listed down below, all I have to do is take a look and add up the sum of the exponents of all the variables. So y is a variable, 8 is not, that's a constant. So my degree is plain old 4. So when I look at 3a, I don't count 3 at all, right? That's a coefficient, but I do have a to the first power. When I look at negative 2, I don't care about negative 2, but I do see 3, 2, and x would be the first. So what do I have to do? I have to find the sum of the exponents of all of its variables. So 2 plus 3 is 5, plus 1 is 6. Then our last one, I don't have any variables, so I have an exponent of 0. Now the next thing we're going to do, degree of a polynomial, is the greatest degree of any term of the polynomial. So if I can do this and identify the degree of a monomial, I can find the degree of a polynomial. Because if I have multiple, so if this was plus 3x to the third, well, this would be a degree of 3, and this is a degree of 4, so the degree of this polynomial is still 4. I'm not going to add those together. You must find the degree of each term, then you're going to pick the greatest degree. So let's try that out. So a couple things we have to do. We have to find the degree of each one. So how many terms do I have? I have one term. The degree of each term. Well, I have 2 here and 1 more. That makes 3. So the degree of the polynomial, so even though it's a monomial, we can still call it a polynomial by definition. So the degree is 3. Number of terms, in our second one I see 1, 2, and 3. I see 3 terms. The degree of each term, so I should have 3 answers here. So 2 and 2, that makes 4 when I add it up. I have plain old 2 here. And 5 doesn't have any variables, so my degree is 0. So the degree of the polynomial, I'm looking for the largest one, and that's 4. The number of terms, 1, 2, 3, 4, 4 terms. So I need a degree of each term, so I need 4 answers. I have 1. I had a to the first power, a to the first, b to the first, so 1 plus 1 is 2. A squared and 1 more, so 2 plus 1 is 3. And we have plain old 16, which is going to give me 0. So the degree of the polynomial, I'm looking for the largest, 1, 2, 3, 0, it's 3. Okay, so that's how we find the degree of a polynomial. Okay, so I'll just vocab, things that you are used to seeing. No math work that's really difficult for you. You can handle all of this. Find the degree of each polynomial, so I want the degree of the polynomial. So if I have 1, 2, 3, 4 terms, that means I'm going to find the degree of each. So this is 0, this is 1, 1 and 1 makes 2, and 1, 2, 3, so I have 3. So 3 is my answer, the degree of A, right, the polynomial. Looking at number A, or letter A, is 3. The degree of B, so I have 2, I have 1, and I have 0. So the degree is 2, the greatest. And since this is a monomial, it automatically becomes the greatest. So it would be the degree. So 2 and 5 makes 7, and 1 more makes 8. The degree is 8. Okay, so now that you know how to find the degree, the next thing we're going to ask you to do is to put them in ascending and descending order. Okay, arrange the terms of each polynomial so that the powers of x, so I'm only focused on x, are in ascending order. Okay, so if you're going to ascend something, remember that's going up. Right? Descending would be the opposite. That's what we're going to do down here. So descending is down. And again, they're only asking about x. So make sure we understand just the basic things. Ascending going up. We're only dealing with x. So the first thing I'm going to do is find the degree of each, dealing with x. So this would be 0, this would be 1, this is 2, and this is 3. So if I want them to go up, I'm going to start with 16 plus. After 0 will be 1, 2x, After that would be minus x squared. I'm going to keep the sign with, and plus 14x to the third. So these are equivalent. Now if they throw x's and y's in there, the only thing I'm concerned with is the x. So here's x to the first, and I don't have any here. So again, I'm going to start with 7y squared. I like to cross them out as I go, that way I don't lose track. So 0, 1, so plus 2xy cubed. The next thing we'll have is x squared, so minus x squared y squared. Again, the minus sign went with, plus 4x to the third. Okay, so that's ascending, going up. Let's take a look at descending. Descending is the most common. Okay. Typically when we write our answers, we will be descending, and again, we will use x. So this is a really good example of how we're going to write our final answers once we start doing the sum and the difference of these polynomials. So I'm again looking at x's, so x squared, x to the first, x to the third, no x's, so the highest one is x to the third, so negative 4x to the third y, x squared, so plus 7x squared, minus 12xy cubed, and plus 8. Okay, so this is for letter A. For letter B, again, they threw in A's and all sorts of different powers on the A's. They threw in Y's, all sorts of stuff. I'm focused only on the X's. So no X's here, so that's got a pretty good chance of being at the end. X squared, x to the first, x to the fourth. So let's go ahead and start with that 9x to the fourth y. And it is negative, so make sure you put that minus sign out in front. To the first, and squared, so plus ax squared minus 2a cubed xy cubed and plus a to the fourth. Okay, so descending order. So like I said, it's not going to be very difficult. All it is vocabulary that we have to get used to. Descending order, and we're talking about the degree of each term of the polynomial. Alright, you guys have been doing this for a long time, you just didn't know it. We're going to add the following polynomials. So what we're going to do is look for like terms. Okay, so let's get some of this out of the way. So we're going to group your like terms. So if I'm going to group my like terms, here's what it looks like all put together. Scroll that back up a little bit. And some of you taught real basic things when you were much younger. You know, put circles on the same y's, you can do triangles on the x's. But, you know, we're kind of beyond all that, but if right now it helps you to see what we're doing here, and keep in mind the sign always goes with. So we did group those things together. And if I have 9 minus 3, so that's going to give me 6. I have negative 7 plus 8 is 1, and I have 15 minus 8 is 7, so that's what we're after right now. So we should have a final answer after we group our like terms. Another method that I've seen very successful for some people in between, they don't want to draw boxes and stuff, sometimes they feel embarrassed with that, is I'll start to underline the like terms. So my AB and AB, they both have a single dash under them because they are similar, and B squared and B squared have 2 because they are similar. So again, the same thing, I just want to clump them together. That's just right over top of that. So I have 3a squared. So this way it doesn't really require me to rewrite it. So I have 3ab, it's positive, plus 4ab. So plus 7ab. I have negative b squared plus 6b squared. So I have plus 5b squared. And they didn't give me instructions on which way to write it, so I'm quite happy with the way it is and its final solution here. I have a squared, I have ab, I have b squared. So there are no more like terms I can put together, nothing else I can do with it. One thing that when we start multiplying, I'm really going to pressure you into doing the column method, right? Column is just like at the White House. We have columns in front of it, right? They go up and down vertically. So one thing you can do is start to get rid of that. We can start by getting rid of that. Right, and we can stack them up. So we line up our like terms on top of each other. So I have 4x squared. My sign in between is plus right here. So I'm going to use a plus sign out here. And I have negative 2xy. And underneath that I have plus negative xy. And I have 3y squared plus 2y squared. So we're going to stack those up and get it going there. And remember which tool I'm using here. Alright, so if we add our like terms, 4 minus 3, again we're going to be adding, but it's a negative 3, so we get 1. We don't have to write the 1 in. Negative 2 plus another negative is negative 3. So it's nicely stacked up. I don't have to train my eyes to look all over the place. All I have to do is work vertically, straight down, and then I get my answer. So it's called the column method. Okay, so you can use any method you want, but I just wanted to show you what's out there. We do have to make sure in this problem that we deal with our negative sign. At this point, many of you are like, yeah, okay, this is 9y minus negative, so that means plus. So I'm going to have 12y. Okay, so that takes care of the y's. I have x's, negative 7 minus 8. The negative 7 minus 8 is negative 15x. And I have 15 minus negative, so minus negative means we're going to talk about plus. So plus 23a. So our final answer. And again, they didn't give us any order to put anything in. So you can use column method, you can use kind of common sense, you can draw circles and triangles and boxes, whatever works for you right now. So I want to subtract the following. So again, they did kind of put everything in order. So maybe this time I'll model 7a minus 10b minus, so that's our minus sign, 3a plus 4b. So the only trick here is to make sure you go from 7a minus 3a. So we get 4a. We have negative 10 for the b's, minus 4 more, so negative 14b. And that would be our final answer. We have a's and b's. They're unlike terms. That's what we can do. Okay, so just model the column method where I stack them up. Whatever works for you. And I do suggest the column method for this one, only because they kind of put everything out of order and there's a lot of signs. But again, it's truly up to you. Just make sure you know that we are subtracting, but I am going to model that because I do think it's helpful. So 4x squared minus 2xy plus 3y squared. Here's my minus sign, the minus in between them. Negative 3x squared minus xy plus 2y squared. So if I have 4 minus negative, that means plus. So 4 and 3 is going to make 7x squared. Negative 2 minus minus, so that's plus. So negative 2 plus 1 is negative xy. And 3y squared minus 2y squared is plus plain old y squared, or just 1y squared. If you want to write 1's in there, it's not wrong. We just start to drop that soon. That's all. Okay, we want to find the sum or the difference. In this case, we're going to find the sum because they're asking us to add any way that you want. Binomial and a binomial, you're probably good here, right? 5a plus 2a, 7a, negative 3b plus 6b, so plus 3b. And last one, so this one is the difference. So make sure you go from first binomial to the subtraction to the second one. So we have 5a minus 2a, 3a, a. Sound kind of Canadian now, eh? Alright, we got negative 3b minus 6b. But what we have here is negative 9b. Right? That's negative 3b minus 6b. So negative 9b. Final answer. Again, it's more about the vocabulary in this section than anything else, and we'll continue to use it throughout the chapter and build on it. So we'll keep getting more practice as needed.